What I'd like to do before I start the formal part of this presentation, I've heard a lot this morning about the challenges that people in this room collectively face. And I work for a company where I spend a lot of my time in Western Europe and in some of the emerging economies of the world. And what you should know is that the challenges you face here are broadly the same that are faced by IT professionals in other countries and other industries. And it comes down, by and large, to culture. I've heard it a lot of times around the room today in terms of the cultural change that is required within people to drive organizational change, because without organizational change, you can't transform the way that people work, the way that people consume or sell services. So, in part, don't feel that you're alone in this. And secondly, as I travel across Western Europe in particular, G-Cloud is seen as the model for how this gets done. Because as an industry analyst friend of mine said, when the original piece of work that started G-Cloud came together, one way you could think about that was, it's amazing what happens when the money gets taken away. Because if you think back a number of years, a large part of the driver for the transformational change in the way that procurement has been done was a direct result of a financial crisis. And what happened here in this country is now seen as pretty much the model for the way that other Western European governments want to run procurement exercises. They are broadly trying to understand how the G-Cloud model works in terms of the creation of a marketplace where central and local government and associated services can actually go to one place and find a competitive area in which to procure on demand the services that they required. Because the days of 7-year contracts where money was thrown bad after good in terms of getting long-term contracts where suppliers could eventually just take a 7-year piece of business and almost guarantee the revenue from it, those days are gone forever. And it's a good thing that they are in many ways, because it allows us to think differently about how we use technology to both procure and deliver services to an endpoint. And if you think about the fundamental principles of the NHS, the fundamental principles of the welfare state, the way in which that gets delivered, whilst the technology might have changed dramatically in the past century, those principles remain true today, and they are still a beacon in the Western world and in the broader world for how this should be done properly. So whilst I absolutely applaud all the stuff I've heard around the room in terms of the openness and accepting the challenges, also recognize that in many countries you're seen as leaders as to how this gets done. And so some of the influences and some of the experiences that you have, I take and translate and actually give messages to other countries in the European Union and beyond about how this stuff needs to get done and what the advantages are to having it done this way. Within the industry broadly, there is a transformation taking place, and it's driven by this thing called cloud. You've heard some definitions of it, some descriptions of it. I broadly agree with all of them. But what you need to remember fundamentally is that cloud is born out of the idea that I can virtualize an application and I can virtualize a service. The days of going to a single vendor and purchasing an application that ran on their hardware are gone, because virtualization allows you to make the break between the application space and the computing environment, the network environment, and the storage environment that underpins that. You can't have cloud unless you have virtualized. It's step one. And in providing virtualization, in many cases, the challenge becomes how quickly can I take advantages of massive commodity applications running in standardized virtualized environments, in standardized compute environments where the economics and the cost of scale over the course of the past 3 to 5 years has dropped through the floor. And to some extent will continue to drop through the floor because of technology advantages and the things that we can do now in these highly flexible compute, storage, and network environments. And what I'm going to spend some time talking about is an instantiation, a physical instantiation of that idea, something we call a VBlock, something that you can acquire in a data center that you might own, or somebody that a G-Cloud framework provider uses as the basis for the IT transformation that you're all driving for, be it paperless, paper light, be it use of consumer electronics devices in GP surgeries or in hospitals, because the way in which that gets delivered, the more that you can standardize it, the better the economy of scale and the better the cost you can drive out of the solution and the system that you're trying to work with. And what we as VCE do, as I'm about to show you hopefully, is provide an experience to either you directly or to providers within the GCLAM framework that very much underpins the principles that you've just heard about during the course of some of the other talks that you've heard this morning. A quick snapshot on us. We were founded in 2009 as a joint venture. The companies that came together to invest in us were Cisco, EMC, Intel, and VMware. They were industry leaders in each of their respective spaces. When you look at data centers and you look at the technology that has to come together to make a data center work, you could argue that no one of those single vendors owned enough of the stack to make a significant impact in the way that you deployed services in data centers. But you bring those technologies together and you then have a transformational approach to how you construct infrastructure. And that's what VCE does. As at the end of October last year, EMC acquired 80% of the assets of our business. Cisco retained an active investment, VMware retained an active investment, but EMC now are the majority shareholder in VCE as a company. And we joined something called the EMC Federation, which is a collection of companies that sit under EMC's umbrella that take a collection of different products and services to market. These include companies like VMware, Pivotal, RSA, and EMC itself. So going forward into 2015 and beyond, we will be part of EMC's federation of companies, and we will retain our identity and our purpose in the market. And I want to talk to you now about what the identity and what that purpose is. The environment, be it a healthcare provider environment or a business environment, is dynamic. Because in the past, IT was always in control. The extent to which applications and systems were developed and delivered were controlled by an IT function that put the desktop on your desk and the phone on your desk. In the advent of consumer electronics, the advent of phones and tablets, that world has been turned on its head, because now the user environment is the environment which is in control. And the platforms like the phones and the tablets, I actually prefer using to traditional desktop environments. The battery life is better, the screen resolution is better, and the applications are simple. And the big reason for the rapid adoption and take-up of this technology is because it's brought computing to a generation of people who would never have used a computer. Because a computer was a scary thing that you went to. Now it's something you carry in your pocket. And the instantiation of the software is an application that you double tap and that you use incredibly easily. And what the application is your business process delivered in code. Booking a hotel, booking a flight, doing your online shopping. You are taking somebody else's business process, you're putting it in software, and you're delivering that as an experience to the consumer. And I would argue increasingly, through the use of technology like this, the way in which we, the general public, access healthcare providers, and access healthcare systems and services, the simpler you can make the experience, two things happen. One, a greater adoption, and two, you hide the complexity of what really goes on to make that thing work. And the simpler it is, typically the better you are doing a job at hiding the complexity that sits behind what needs to happen to deliver that calendar appointment at the GP surgery, to deliver that calendar appointment to have an X-ray in the local hospital. So simplicity will beat complexity every time, and what these vendors, the Apples and the Googles of this world, have shown us is if you make things simple, you will get a rapid and massive adoption at scale of the technology. And as I said, it's brought computing to a generation of people who would never have thought they were using a computer. The IT environment in which we've sat in is the very opposite of that. As vendors, we have encouraged IT departments to be systems integrators. Take the best-of-breed Cisco, the best-of-breed EMC, the best-of-breed vendor Y, and you put it together yourselves. Because if you do that, you end up with a solution which is just about right for the one environment that happens to serve. And when you've got time on your side, and when you've got perhaps a little more degree of flexibility in the budget, that's a perfectly acceptable approach. But these days, neither of those things are true. You do not have time, And IT budgets tend to be constricting and constraining, not expanding. So you have to rethink how you build infrastructure. Because a best-of-breed approach where you put all the components together yourself, I would argue, is not optimal in delivering rapid application turnaround, rapid application deployment, or expansion of an existing capability. You need to standardize. The world is standardizing around virtualization and x86. Those are the things that you are getting locked into. And when you think about the different vendors that approach the virtualization world and the x86 world, you have a huge amount of choice in terms of vendors that compete to offer infrastructure where that is what you see as a resource that you can use to develop applications in. The vendors that we work with, EMC, Cisco, VMware, are the recognized leaders in each of their spaces. But rather than have you integrate the product yourself, it's something that we as VCE do. We believe it's the foundation for cloud-based technologies. A number of the G-Cloud providers that were mentioned on the previous slide, our technology is accredited and used in their data centers. Under the old nomenclature, we are accredited up to IL6, or top secret as it's now known. So the technology that we provide to the G-Cloud providers is often the infrastructure that you are using. It might or might not be advertised to you, but in many cases, that is the foundation for a number of providers who sit within the G-Cloud framework. And there are a number of things that they don't do because we do them for them. And I'll walk you through what that experience is, so that maybe if you're looking to acquire this asset into your own data center, or maybe as you're looking to evaluate certain G-Cloud providers on the marketplace, you can ask them the questions about who fundamentally underpins what they do, because there are a set of rules and a set of definitions that if you get this right, we think provide a dramatically different experience both to them and as a direct result ultimately to you as well. We build this ourselves. We build the technology, the infrastructure which underpins these services, and we have put a huge amount of engineering rigor into the way in which this technology physically gets constructed. We physically construct it in Cork in the west of Ireland or Boston on the east coast of the US. What the G-Cloud providers or you would come to us with is a set of requirements. I need to run these applications, I need to run these workloads, I need this amount of storage capability. Can you design me a system based around a set of standards that would match the requirements that I've just given to you? And we then negotiate in terms of what it is that we physically construct, but we physically build these entities. They arrive as pre-built systems anywhere between 0 and 45 days after a commercial engagement has begun. And if you think about the time it takes just to procure the individual components that make up the asset, this itself can be a significant reduction in time to actually just getting a system and a solution delivered on a data center floor and ready to go. We also then spend some time with either you or the providers providing a basic level of education around the system that we provide. This thing comes pre-built, and as it leaves our factory, it leaves in a known good state. We educate your IT teams about what that known good state is, because within the stack, there are individual software components that run at the storage layer, the network layer, the virtualization layer. And the key to keeping the system stable is knowing the condition of each of those software components and knowing what a known good state looks like. So as you wish to upgrade or update these systems in the future to take advantage of new capabilities, for example, you will need to move from a known good state to another known good state. And having active knowledge about all of the software components that run in the stack is a massive asset, because it allows us to show you how to do the update or the upgrade, because we will have tested it first. We will break the systems in our labs. We will get the respective industry vendors to fix their code before we ship or publicly announce what the update process is. It's a huge amount of intellectual property that we as a company invest in, but we share with our customers. And it takes the risk out of the process of update and upgrade, because we break it before it gets announced to the public world in terms of how you go from, let's say, known good state A to known good state B. So it's a very different experience for the providers that take our technology, because from day one, they see it as a system. rather than a set of individual components. And 2, we know the exact state of that system as it leaves our factory, and we can provide advice on how you change that known good state as you look to update or upgrade the process over the course of time, over the lifetime that you own the asset. This whole process is called the release certification metrics. As I said, it's intellectual property that VCE owns. We're a company of about 2,500 employees. 300 of our employees are engineering staff that work on understanding the code interactions between the Cisco, the EMC, and the VMware components that sit in that technology stack. And the RCM is what we publish. It's an update. It shows you how to go from known good state A to known good state B. And in doing that, we significantly reduce the time it takes, the risk associated with the upgrade and the change, and we provide a much more stable environment for people to make changes in the infrastructure without bringing an application down or without disruption to service. Whilst it didn't happen in 2014, many of you might remember national newspaper headlines from 2013 when banking systems failed, when people couldn't get money out of ATM machines or couldn't use their credit cards at checkouts. You just know that someone somewhere tinkered with something. They brought down a system that was then unrecoverable for hours thereafter. You can almost guarantee that in the background, that's what happened. Anything that you can do to reduce the risk associated with change, to provide non-disruptive in-service updates and upgrades is a massive benefit to either you or to the G-Cloud providers who use our technology. And this is a significant benefit because it allows us to show to the marketplace the known good state and how you go from known good state A through known good state B in a way that absolutely minimizes the risk associated with change. We all want to take advantage of new features. We all want to upgrade to the latest versions of code. In doing that, you have to make sure that you understand the interdependencies and that you need your vendor to test them for you and to be in direct touch with the vendors to get the code rewritten before it actually hits the more public domain where these changes can be seen in a very, very public, very, very forefront way. It's all very well and good us talking about how we physically build this infrastructure because that's what this is. We have to take a radically different approach to the way that we manage it. In the past, we have seen the storage component, the network component, and the virtualization components as separate entities. We have teams of people who are specialists in each of their respective domains. A vBlock is not that. It is the sum of all of those parts and then some. Because the engineering teams that manage vBlocks manage a set of resources that applications run in. And if you think of a vBlock and if you think of this technology in that domain, then you're thinking correctly about how your IT teams can use it to develop applications. We talk about digital marketplaces. We talk about applications being made available. There's a whole development community out there that has to create these applications. They need environments spun up very quickly where they can do testing, where they can do development. And if you're a Facebook employee, certainly a coder at Facebook, it's generally common law that they encourage you to publish your first application at the end of your first working day in the organization. The reason they can do that is they have a culture that aggressively pursues excellence in code, and they have a technology platform that allows them to take the development environment and make it a runtime environment very, very quickly. What you see in a vBlock is a very, very similar approach in terms of the platform's ability to flexibly allow you to deploy the resources that you need to deploy quickly so that application developers can test and then run to production the applications which they're trying to get out to the front of the field, to perhaps GPs, to perhaps clinicians who want to start to use and look at these applications and how they might transform an element of patient care within a certain environment. So don't think of it as just individual bits of kit. It is not. It's a radically different approach to the way that infrastructure is designed and delivered. We've shipped probably 2,500 of these units worldwide. We have a 0 failure rate as they leave the factory. And there are organizations across many different industry verticals, including healthcare, that use these systems to run mission-critical applications 365 days of the year. So this technology is proven, and it's proven in some of the most demanding and harshest computing environments that you can find. because at the end of the day, our reputation is very much based upon our ability to stand behind some of the commitments and the guarantees that we make to customers who acquire our technology. And we had it independently verified. IDC, the market research company, we asked them every year to conduct an interview with customers who've acquired the V-Block technology. And we asked them a very simple question. What was life like before you had a V-Block? And what is life like after you've acquired that technology? And whilst this is just a snapshot of the results, there's typically a 13 to 15-page report that sits behind this. These are some of the numbers that drive change in IT organizations. The ability to more rapidly spin up application environments. The dramatic reduction in downtime associated with using a V-Block versus a build-it-yourself approach. The ability to go from application development to production, typically 5 times faster than you were seeing before. And if you measure the lifetime of the asset over 3, 5, 7 years, you'll all have your different accounting principles to how you do this. When you start to add up not only the capital cost of acquiring the asset, but more importantly, the operational cost associated with running it, then you start to see savings of the order of 50% in large enterprise IT organizations. And sometimes this is a function of having engineers not have to spend time testing vendors' code because the vendor does it for them and publishes the upgrade path, as I've already talked about. So when you do TCO calculations and ROI calculations on our technology, as you start to look at it over the lifetime of the asset, the acquisition of this allows you to run a significantly lower cost operation in terms of the way that your data center provides service to the application developers and ultimately to people who use technology in everyday parts of their lives is what they do. So that's what we do. That's why we're different. That's where we've come from. That's very much what our proposition to the marketplace is. And whilst you might not want to acquire our technology directly in your data centers, be assured, as I said, that a number of G-Cloud providers who you might contract with use this technology to underpin the services that they provide to you. And for those of you that are looking to acquire this as technology that you run in your data centers, again, we would welcome a broader conversation with you about how this technology will allow you to transform parts of your IT organization and the way in which you deliver service to people within your facility. At that point, I'd like to stop because I'm just on time. And I think we have a session on the sofa. So thank you very much for your time and attention, ladies and gentlemen. Let's move to a Q&A. Thank you.
So in terms of responsiveness of the healthcare sector to the kind of proposition that you guys present, what has been the uptake, both here and obviously VCE as a global organization? Has it, I know in the States perhaps you've had more traction than you have over here?
Yeah, so we have a gentleman with us, Chris, at the front of the table here. So Chris is directly engaged in selling into many of the NHS trusts, many of the organizations who at a local level would acquire our technology, and my colleague here from EMC will have a broader experience. So we've, I think, made some good inroads and some good impacts. Certainly in the US, where you have a medical system perhaps driven from a different financial model, the changes there have been dramatic because the requirement to do transformation has been equally dramatic. But you might argue that there's a different approach to how they do that. But this is wholesale change. People don't tend to do this in bits and pieces. This represents wholesale change. And so, as I talked about at the beginning of the piece, if you're culturally preparing for how you do wholesale change, we fit that model very, very well. And as organizations increasingly embrace the change that represents, we look like a very good fit for how you provide infrastructure to make that happen.
I was interested in the sort of link you made there between virtualization and cloud, and you were talking about virtualization, I think, as a sort of a first stage towards cloud. When we think back to pre-G-Cloud days, the first idea for G-Cloud was going to be based around virtualizing data centers first and foremost, and very different to what it's ended up being. Are we sort of seeing a resurgence of interest in virtualization in that sort of G-Cloud, public sector cloud context now?
Again, not wanting to speak directly for the G-Cloud people, but it's a mandate. It's mandated, right? It's almost the base level of something that you need to do. We talked to a number of enterprise organizations across many industry verticals. And one of the questions you typically ask is, how virtualized is your estate? And you typically get numbers in the 50 to 70% range is a good typical number. You get people in the upper 80% more exceptionally. But what those people have done is they have taken legacy applications that they will have to physically rewrite, and they have decided that the cost associated with maintaining the way it was is now it's uneconomical versus actually the cost of rewriting the application. Right. So you get the majority of takeovers that virtualization, typical 80-20, they'll do 80% of the applications first. The last 20% tend to be the hardest to do because it requires some sort of rewrite. But as you get towards that higher level of virtualization, the cost base associated with legacy drops to close to zero. Mm-hmm. So over time, you see how the economics play out, but you have to take it almost easy pieces first, harder pieces towards the end.
I was just going to add, what you've got there is quite considerable amounts of data being held in these legacy. And we've talked earlier about the information governance requirements to store the data. That is the challenge, in that most people look at that within the NHS and say, well, actually, we can't move our clinical applications into a cloud environment because of the way they were written, how old they are, and they've got to make that transformation first. So within EMC, VCE is an absolutely fantastic acquisition. Well, it's not an acquisition, it's a joint venture with us, but it's helping us in terms of getting across that message that you've got to move from where you are now. Yes, we want you to go to cloud. There has to be a hybrid model to get you there in the middle because of this issue with keeping your legacy data centers and your legacy applications in your data centers, but actually trying to get everyone onto a cloud environment moving forward. And with VCE as part of the family now, we feel we've got that final piece of the juggle to enable you to manage your in-house with your cloud. Someone mentioned earlier about cloud environments and actually being able to move between them. We have the technology to enable that so you can manage across all of your cloud environments as well. Even Amazon with their S3 technology, which has historically been quite tricky to do. So we cover every base there, and it's all around this open standards that we talked about earlier as well.
So just one last question before we break for lunch, but we've talked a lot today about the sort of inherent conservatism of the small c in the NHS, across the healthcare sector, about moving towards the cloud for information governance reasons and all sorts of other things. Do you get a feeling that the time is ripe now for a sharper uptake?
Yes, absolutely. There's functions of the buying cycle. So where are you in terms of the asset that you own? Is that written off now? Could you go and look to acquire a new approach to doing things? So there's a timing element to this. That's the first thing. But for people who are coming to the end of that buying cycle where the asset has been depreciated, there is now a very dramatically different way of how you would approach acquiring a computing capability. Mm-hmm. With legislation, I totally get as somebody who has his medical records on paper somewhere, I totally get the privacy concerns associated with that. There is, in my opinion, no one right answer to your cloud approach. A mix of private and public seems to be the way the industry is investing at the moment, and the comment around the ability to move data between clouds has been challenging, but the announcements, certainly from EMC, VMware last year, were deliberately designed to make putting data up there and getting it back relatively seamless and relatively easy. And G-Cloud providers can use that technology, embed it in their offering, so that you have a very low-cost data store in the public cloud for data which you consider less sensitive, and the ability to anonymize that and move it between your private and your public clouds is becoming a lot easier. So there's an imperative now around the ability to do that. And finally, you start to see, and many of you might have seen commentary from CES, the Consumer Electronics Show last week, about the proliferation of digital devices that people wear as active monitors of their health, the ability to connect those systems and to make a medical decision based on real-time data is where you could start to see this direction heading. So we need to be increasingly comfortable with public cloud spaces and the public data which is potentially available, because it can deliver a different clinical outcome. But it has a dramatic effect on how you store data, where you store data, and the analytics required to deliver a real-time result.
I think just to add to that, the other change is going to be is around risk. And what we've seen and heard today is that the risk has been drastically reduced. 2 years ago, people wouldn't move to cloud because they thought it was a high risk compared to having it in their own data center. What we're actually seeing is there's been more breaches of in-house data centers than there has been in the cloud. So, that myth is now gone, but also the standards around the G-Cloud and the security that people have to comply with means that actually it's probably more secure, well, it is more secure than you probably have in your own data center. So that myth has also gone. So the people I'm talking to, they're looking at cloud. What they're trying to do now is they're trying to work out how they can move from where they are now to cloud. What is their roadmap? But, cloud is ultimately their end goal.
Okay, well with that, Nigel and James, thank you very much indeed.
Thank you.